Now this is the handwriting physics, and the topic is neutrino oscillation. I typed these things from the textbook of the particle physics written by Thomson. Okay, maybe I will use some pen. Yes, yes, and I use some of the Zoom to record the video. And I think it will be helpful to understand the physics and also speaking English practice myself. So today topics I already mentioned that the neutrino oscillation. Multiple courses on the high level physics, which is the familiar for me. So there are some of the two kinds of the neutrino eigenstate. The one is the Bleibert eigenstates. There are electron neutrino, mu neutrino, and tau neutrino. Such a Bleibert eigenstates are coming from the each weak interaction between the production or detection, and it can be converted in the mass eigenstate, mu1, mu2, and mu3. And between them, there will be some unitary mixing matrix. For simple case, we will discuss about the two-Bleibert system, and the unitary mixing matrix is given by the rotation matrix with the angle theta. And let the initial state is equal to the electrons neutrino. It will propagate with each mass eigenstate. So Bleibert eigenstate will be converted to the mass eigenstate with the mixing matrix component. And during the propagation, there will be the time evolution factor will be multiplied for each mass eigenstate. So mass eigenstate has the mass price during the propagation. And at the distance L and the time t, such a time evolution factors can be represented like that. Another time minus momentum and distance, and it can be described as just a pi I. So we calculate about this eigensize at the distance r at time t. Then it can be represented like that. There are mass eigensite, mixing matrix components, and time evolution factors with the pi's. And if we convert each mass eigensite to the Bleibert eigensite with the mixing matrix component again, also for the second term, U2 become new E and the new mu as a linear combination, and there are remaining phase factor term. If we rearrange the ones with each Bleibert eigensite, there are new E in here and new mu, and there will be the coefficient of the each terms can be represented like that. We know that the scalars of the coefficients in the quantum state is the same with the probability in the quantum mechanics. So we can calculate the detected probabilities of each Bleibert eigensite at distance L and time t. It is called the neutrino oscillation. So let's calculate the scale of this coefficients in next page. Not next page. Yeah, there is a scale of the coefficient. So in case of the second term, if we scale of this coefficients, there are some calculation process. Cosine scale theta, sine scale theta, and exponential minus I pi 2 minus exponential I minus I pi 1, and its conjugate. And using the some trigonometry, some identity, we can obtain that sine square theta and the sine square delta pi 1 2 over 2. So we can represent this difference of the pi's delta pi 1 2 in terms of the neutrino mass, because in the previous case of the formula, this pace is represented with the energy and momentum and the distance and time. And using the relativistic simulation, we can represent this pace in terms of the mass. Maybe in the next page. So a pace difference is can be written by like that, and we start the three momentums as all equal for the each fiber. So this term is equal to the 0, and such energy can be written as p squared plus m squared and its root as a relativistic relation. And because m is extremely small, neutrino mass is extremely small compared with the neutrino's energy. So expansions of this root, we can obtain this term also for the second term. And we will start the momentums is similar to the energy. And the time is similar to the distance. So such a pace difference can be written like that. There are mass scale difference and neutrino's energy and detected distance. So if we input this pace difference in terms of the mass scale difference for the previous calculations as just scales of the coefficients for the quantum state, then we can obtain the mixing probability. The first time the initial state is electron neutrino, but it will be converted into the mere neutrino with this probability. And the first component is regarded as the mixing matrix component, and the second term depends on the mass scale difference, detected distance, and energy. So we can obtain the surviving probability in the two probable case. Electron neutrino will be survived in the electron neutrinos with this probability, that's just a 1 minus of the previous one. So if we plot the surviving probability in terms of the distance with the fixed energy will be some fixed something, and it can be plot like that with this function of the sine. Such amplitude is depends on this mixing matrix components sine square to theta, and the period or frequency depends on the mass scale difference. So from the such oscillations behaviors that are the supposed to be neutrinos experiments, we can obtain the such a mixing angles theta and the mass scale difference delta sum case. But that is a very easy case with the two flavor. So now we will go to the three flavor case. It is the most complicated process, but almost similar. From the identities of the orthogonal matrix, unitarist matrix also has the sign properties like that. With the sign columns, the product of is yield a 1, but the different columns is orthogonal, so it will be the 0. So with the sign process, we will start the initial state is equal to the electron neutrino, and it can be converted into the linear combinations of the mass eigenstate. And after the propagation at distance x and time t, there will be the time evolution factors in D, and also mass eigensite can be converted into the linear combinations of the Bleiber's eigensite. And if we exchange of this such a summation, then we can rearrange the monster of the contemplate as a linear combinations of the Bleiber's eigensite, and there will be the coefficients for the each Bleiber's eigensite. So if we scale up this coefficients, then we can obtain the probabilities of the mixing into the Bleiber's eigensite nu chi. Chi is equal to the E, mu, and tau. So let's calculate about the scales of these coefficients. So for the case of the surviving probability, we will scale up the such coefficients from the previous one, and we use such identity of the complex number. Then from this, we can obtain this, and from this, we can obtain this. And from the identity of the unitary matrix, from this term and some this term will be gives the just one, and the remaining terms will give the this term. And there will be also phase scale difference. We already seen in the two-flavor case, and such a phase scale difference can be written as a sign scales, and also such a phase difference can be written as a mass scale difference, and the distance and energy. And we will parameterize of the such a 3x3 unitary matrix, which is 3 parameters. So there are 3 angles. There are theta 2, 3, theta 1, 3, and theta 1, 2. And such a multiplication of the 3 matrix will be gives the mixing matrix of the neutrino relation. It is so-called the PIM M and S matrix. So if we insert that such a mixing matrix component from here, and the summation of that, then we can obtain the mixing probability in terms of the mixing angles and the mass scale difference. That's some of the final result. So that is some of this surviving probability in the three Bleiber's type. There's delta Salaman 2 scales and the delta Salaman 3 scale. And we assume that the delta M13 and the delta M23 is very similar. So we did absorb it in this term. If we plot the surviving probability as the functions of the distance L, then the overall tendency is the sum with the two Bleibers from this term. Amplitudes coming from the design scales to theta 1, 2, and the frequency from the mass scale difference delta theta 1, 2 scales. But from the second term, there will be the very small oscillation behaviors in D, because the delta M1 scales are extremely bigger than the delta theta 1, 2 scale, so it makes the very strong oscillations. And the sign scale 2 theta 1, 3 is smaller than the sign scale 2 theta 1, 2, so its amplitude is very small. So that is just some of these behaviors of the three Bleibers oscillations with the neutrino. And the neutrino oscillations is a strong evidence of the neutrino's mass is not equal to this 0. So we demand the beyond standard model for the neutrino mass is necessary. And there are the various models, for example, seizure mechanisms that are introduced to explain the neutrino mass. And I will explain about the seizure mechanism and some of the additional phenomena studying the neutrino oscillations in next time. Maybe